Dear children, good morning. Today I am going to start chapter Rational Numbers. It is the first chapter, a book by Selena Publication. Let us begin with introduction. We start with the definition of natural numbers. Natural numbers. The numbers 1, 2, 3, 4, 5 onwards. That is the counting numbers are called natural numbers. We call them natural numbers. If we include 0 to this collection, the new collection formed will be called whole numbers, right? And if we take all whole numbers together with negative of natural numbers, this new collection formed will be called integers. In fact, set of integers, right? So when we begin counting from 1, 2, 3, 4, 5, 6, 7, 8, 9 onwards, we get natural numbers. If we include 0 to this collection, we get set of whole numbers. And if we take all whole numbers together with negative of natural numbers, we get set of integers, right? And next is rational number. You can note down rational number, right? See, a number that can be written in the form P by Q. A number that can be written in the form P by Q, where P and Q are integers and Q is not equal to 0, is called rational number. For example, if I take 2 upon 7, okay, 2 is integer, 7 is integer, and of course 7 is not equal to 0. Therefore 2 upon 7 is valid to be called rational number. We can take more examples like minus 3 upon 8. Here minus 3 and 8 both are integers and 8 is of course a non-zero. So here minus 3 and 8 are integers and of course 8 is non-zero number. Therefore this minus 3 upon 8 is also a rational number. Now taking further a discussion, we can say all integers like a 2, 3, minus 7 are also rational numbers because these can also be expressed in a rational form. 2 upon 1, 3 upon 1, minus 7 upon 1, etc. It means we can say all integers are also rational numbers. What about 0? 0 can be written as 0.1, 0.5, right? So 0 can be expressed as a fraction with a non-zero denominator. Therefore, 0 is also a rational number. 0 is also a rational number. So we must keep in mind that every natural number, every whole number, every integer, and every fraction is a rational number. You see, all natural numbers are contained in set of whole numbers, and all whole numbers are contained in set of integers. As all integers are rational numbers, this automatically validates the idea that all whole numbers and all natural numbers will also be rational numbers, right? Also, you keep in mind, if in the rational form, let us say P by Q, if GCD of P and Q is 1, that is P and Q have no other common factor other than 1. P and Q have only one common factor. So next is, see, if P by Q is a rational number, then P will be called numerator. And Q will be called denominator. For example, if I write 2 upon 9, here 2 is numerator and 9 is denominator. 9 is denominator. See further, for a rational number like 2 upon 7, and this is 7 with a negative sign. It is convention to write negative sign if present on the top side. So we write it like minus 2 by 7. So negative sign if present with one of the integers should be moved to the upper side. Then what about further, what about the sign of rational number? See, if a number, let us say 3 upon 4, it has top side, bottom side, both integers with a positive sign, or minus 3 upon minus 7, both integers with negative sign. Then the rational numbers 3 by 4 or minus 3 by minus 7 will be having positive sign. That is, we say the rational number 3 by 4 is positive rational number. 3 by 7 is also positive rational number. That is, rational number will be positive if both numerator and denominator have same sign. And in the case, the sign of numerator and denominator is opposite. We say the rational number is negative, right? We have many more properties of rational numbers. Say if m is any non-zero integer, let us say m is equal to 2, which is of course not equal to 0, then for a given rational number, say p by q, we can multiply it by m on the top and bottom side. The new number, that is pm by qm, will be same as p by q, or even we can divide p by m and q by m. So the numbers formed, the rational numbers formed, this one or this one, will have same value as the original rational number p by q. Hope you understood. Then the next property is, if a upon b and c upon d are two rational numbers equal to each other, then we can cross multiply them. That is, AD is equal to BC. For example, let us say we write 2 upon 7 equal to 8 upon 28. Both are equal rational numbers. So let us cross multiply these. This becomes 56. This also becomes equal to 56. Right? Sometimes we may be asked to find value of like unknown variable 2 upon 7 is equal to x upon 4. Find x. So what we do? We simply cross multiply. It is 7x is equal to 8, or x is equal to 8 by 7, which I can write 1 whole 1 by 7 as a mixed fraction. Right? Mixed fraction. Then we take properties of addition of rational numbers. Properties of addition of rational numbers. First is closure property. CLOSUR. Next is properties of addition of rational numbers. We start with closure property. Closure property. CLOSUR. closure property. See, when we add two rational numbers, the result is always a rational number. In fact, closure property means if from a set, from a well-defined collection, if we take two elements and on being operated under some operation, the resulting element belongs to the same collection, we say closure property is satisfied. I can take one simple example. Let us say 4 and 5 are two natural numbers, and if I take addition operation, then 4 plus 5 is equal to 9, and 9 is also a natural number. It means 4 and 5, 4 and 5, 4 and 5 when added, the result belongs to same set, same collection. Therefore, the closure property under addition holds good, is valid in case of natural numbers. Similarly, in case of rational numbers, say if I take two rational numbers, say 3 by 5 and 4 by 5, on being added 3 by 5 plus 4 by 5, 5 is LCM of course, it becomes 7 by 5. So 7 by 5 is also a rational number. Therefore, we can say that in general, sum of two rational numbers is always a rational number. That is, the closure property under addition holds good in case of rational numbers. Right? So we can write the generalized result, that is if A upon B and C upon D are two rational numbers, then A upon B plus C upon D, the sum of these two rational numbers, is also a rational number, is also a rational number. It belongs to Q. Q stands for set of rational numbers. This is a symbol for belongs to. Belongs to. The next property under addition of rational numbers is commutativity. Commutativity. C-O-M-M-U-T-A-T-I-V-I-T-Y. Commutativity. Commutativity. Right? This property says that two rational numbers can be added in any order. The result will always be same. For example, if I add 2 plus 3 and 4 plus 3, result will be 6 plus 3 equal to 2. Or I add 4 plus 3, 4 by 3 and 2 by 3. The result will be again 6 by 3 equal to 2. So here, while adding, the order was reversed, it was changed. On changing order, the result did not change. The result did not change. So we say the addition of any two rational numbers is commutative. So in general, I can say if A upon B and C upon D are two rational numbers, then A upon B plus C upon D equal to C upon D plus A upon B. Right? Thank you.